Ratios are incomplete if we don't look at them in similar figures. This topic is not different at all. We have already covered this in similarity and congruency in additional topics. Let's revise some of the rules before I dive into the questions. Two polygons are similar if and only if their corresponding angles are congruent, that is, they're equal, and their corresponding sides are in proportion. Remember, if the ratio of the corresponding lengths is A ratio B, then the ratio of their areas is A squared ratio B squared, and the ratio of their volumes is A cubed ratio B cubed. This is very simple. You need to understand that the length is always in centimeter or meter or any other unit that we have. But the areas are always squared. We have centimeter squared, meter squared, and so on. So how do you jump from here to here? You square the lengths. That is why we have this rule. So if you have corresponding lengths, you square them, you will get the ratio of the areas. Please remember this. Now let's have a look at a question. Okay. In the figure above, the ratio of the circumference of the circle O to the circumference of circle P is 2:3. Now circumference is basically length. So we have the corresponding lengths. If the area of circle O is 20, what is the area of circle P? So we have the ratio of the circumference of circle O to P is O ratio P. This is the ratio of their lengths. So if I square these, what will I get? I will get the ratio of their areas, A1 over A2. A1 is basically the area of circle O and A2 is the area of circle P. So the ratio of their areas is 4:9. Now you know 4 represents O and 9 represents P. You can simply now use proportion. That's it. Very simple. So if 4 represents 20, 9 will represent how much? Very simple. Cross multiply. 4x equals 20 into 9. 20 divided by 4 is 5. 9 into 5 is 45. This is our answer. Let's have a look at another question. The figure above shows two equilateral triangles. Okay, we've got two equilateral triangles with side A and side B. Okay, if A over B equals 5/2, we have the ratio of the corresponding sides. That's good. And the area of triangle ABC is 30. The area of this triangle is 30. What is the area of triangle RST? Well, this is a straightforward question, just like we've done earlier. The first thing that we need to do is square the sides so that we get the ratio of the respective areas. So the ratio of the areas is 25:4. Simply apply proportion now. 25 represents 30. 4 will represent how much? Or 25 over 4 equals 30 over x. Do the calculation, cross multiply. We will get 25x equals 30 into 4. You know the drill. Please do not multiply. X equals 30 into 4 divided by 25. So this is basically 6. This is 5. We are left with 6 into 4. 24 divided by 5, which is 4.8. This is our answer. Let's have a look at another interesting question. In the figure above, the ratio of the lengths AQ ratio QR ratio RC is 2:2:3. So AQ is 2, QR is 2 and RC is 3. If the area of quadrilateral PQRS is 48, PQRS, this shaded region, okay, is 48, what is the area of triangle ABC? So our target answer is to find the area of this bigger triangle. Okay, first of all, you need to examine the figure. Remember that strategy? Whenever you have figures, you need to extrapolate the figure, you need to draw on the figure. If you keep looking at the figure, trust me, nothing will happen. Now, if you examine closely, you will see that you have got three similar triangles. The first one is this RSC, the second one is this triangle which is QPC, and the third one is the bigger triangle, that is ABC. And the best part is we have the ratio of their corresponding sides as well. RC ratio QC ratio AC. We have these sides. RC is 3, QC is 3 plus 2, 5. You need to add these up. And AC is 2 plus 2 plus 3, 7. Now what do? We know that we have the ratio of the corresponding sides. If we square them, we will get the ratio of the areas of these triangles. So let's square them. 3 squared is 9, 5 squared is 25, and 7 squared is 49. These are the ratios of the areas of these 3 triangles. But we are not done yet. These are the ratios, these are not the exact numbers. This is where I apply that strategy that if I multiply a number, a constant with ratios, I will get exact areas, I will get exact numbers. 49x is the exact area of triangle ABC. If I ask you what is the area of triangle ABC in terms of x, you will say it's 49x. What is the area of triangle QPC? You will say it's 25x. Similarly, what is the area of the smallest triangle RSC? It is 9x. So if I subtract 9x from 25x, which is the area of this triangle, I will get the area of this quadrilateral. So basically the equation becomes 25x minus 9x equals 48. There you go. We will get our multiple Rx. 16x equals 48, x equals 3. Simply replace x equals 3 over here and we will get our target answer. 49 into 3 is 147. This is our answer. You can also find out the other areas. The area of triangle QPC is 25 into 3, that is 75. And the area of triangle RSC is 9 into 3, 27.